Okay, we are talking about operations with radical expressions. And for some of you, this is going to be a very complicated lesson, and it's probably going to be a long lesson. You might find on some of these problems that you have to go back and listen to my explanation again, or you might need to look in your textbook and see the examples in your textbook. You might even want to watch a personal tutor video on your ebook. So you have a lot of opportunities, but you're going to have to work at this one. It's not, super easy or anything. We've talked about simplifying expressions with nth roots like square roots and cube roots. Now we're going to simplify radical expressions. So we're going to have the variables in there. And we're going to add, subtract, multiply, and divide radical expressions. The adding and subtracting, we've actually done a little bit of that before, so that part of it won't be so bad. And, so there's going to be parts of this that are familiar to you. Some new things, rationalizing the denominator, which is an important concept that you need to be able to do. Finding like radical expressions and what is meant by a conjugate. We'll be talking about that. So for this first one, and I'll just briefly, I'm not going to go over all the wording in here, but just if you look at this example, if you are multiplying and you have like roots, like if they're both square roots, so the square root of 2 times the square root of 8, you can just multiply them and you get the square root of 16. And then the square root of 16, 16 is a perfect square, so you get 4. So that's it. So that's good to know. If you have a cube root, like the cube root of 3 times the cube root of 9, since they're both like roots, they're both cube roots, you can multiply. 3 times 9 is 27. And so the cube root of 27, because 3 cubed is 27, then we know that the cube root of 27 is 3. So this is going to be important to us to be able to simplify, to do some of the things that we're going to do. And you'll see that, but that's important. So to simplify this problem here, the square root of 25, a to the 4th, b to the 9th, we actually did these. And I put a little 2 right here. Remember, if there's not one showing, it's a square root. Now, you're going to want to do the square root of 25 like we've done before. That is a perfect square because 5 times 5 is 25. So the square root of 25 is just 5. So we would get that. To get the variable portion, remember when we talked about this, 2 goes into 4 2 times. So I'm going to have an a squared. And there's nothing left over. So I'm not going to have anything left over inside the radical sign. So now I'm going to do the same thing here. 2 goes into 9 4 times. So I'm going to have a b to the 4th. But there's 1 left over. So the 1 left over is going to stay inside. And this is my answer. Okay, so again, the square root of 25 is just 5. You don't do 2 into 25. Actually, you could if you wrote it like this. The square root of 5 squared, a to the 4th, b to the 9th, then you can even do that. 2 goes into 2 one time with none left over, so we had a 5 out here. 2 goes into 4 2 times with none left over, so you have an a squared. 2 goes into 9 4 times, so that's why this is a 4, with 1 left over. So then, and you could put the 1 here if you want to, but you don't need to. So this is your answer. Okay? The next problem is cube root. So off to the side, I'm going to think about this cube root. Well, actually, I am going to rewrite it this way. So you might have to kind of mess around on your calculator a little bit to break down that 125. And you can see that you will get 5 cubed. You can check that on your calculator. So I'm going to rewrite it like this. So then 3 goes into 3 one time with none left over, so we're going to have a 5. Think about it. The cube root of 5 cubed is 5. So 3 goes into 30 10 times with none left over. And 3 goes into 20 6 times, because 3 times 6 is 18, and there's 2 left over. So we're going to have the cube root of p squared, because the 2 that are left over have to stay underneath the radical. Don't forget your cube, the cube root. So you have to put it there. If it's square roots, we didn't have to put there. That one I didn't need a 2, but you have to put a 3 if it's a cube root. So this would be your answer. Okay, go ahead, pause the video, try this one. All right, so if we're taking the square root, now hopefully you just know the square root of 16 is 4, okay? So this 4 squared is 16, so the square root of 16 is 4. So we're going to get a 4. 2 goes into 2 times with none left over, so we get an x squared. 2 goes into 11 5 times with 1 left over, so the leftover 1 has to go in here. So then my answer is A. I do want to say one thing on this. I'm going to break this all down into perfect squares because it's a square root. So this is 4 squared. I can think of this as x squared times x squared times y 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 squared times y. So the reason I was breaking them all down into perfect squares is because I'm taking the square root. So the square root of 4 squared is 4. The square root of x squared is x, but I had to do it twice, so I get x squared. Each of these, notice I have 5 of them, so I get y times, when I take the square root, I get y times y times y times y times y. So that's why I had y to the 5th. And this one is not a perfect square, so it stays inside. This is your answer. But I just, in case some of you needed another visual, this is kind of really what's happening. My little dividing thing is just a shortcut. Okay, so go ahead and try this one. So you might want to pause it and try it. All right, if you can show on your calculator that 5 to the 4th power is 625, which means the 4th root of 625 is 5. So we take care of the number part. Then 4 goes into 28 7 times with nothing left over. And 4 goes into 23 5 times with 3 left over. Don't forget your 4th root. So we get this. However, we have an even root. And for the b to the 28th, we had an even root, an even power, but my answer had an odd power. That was the situation where we needed absolute value in that previous section we talked about. Now I don't need it around the k to the 5th because even though this was an even root, this was an odd power. So I don't need the absolute value. Again, the reason why is the value of b could have been negative right here. And when you raise it to an even power, then it's positive. And so, but maybe b was actually negative. So then out here, that's when we have to involve the absolute value. So then if we look for which one it is, our answer is C. Okay, on this next part, and I'm not going to even go over all this. You can look at that later, but I want to just focus on rationalizing the denominator, and I'm just going to tell you what that means. That means we cannot leave a radical sign in the denominator. It's okay to leave it in the numerator, but you can't leave it in the denominator. So we have some strategies, some things we have to do to get rid of the radical sign out of the denominator. So for example, for this first problem, this is square root, by the way. So the first thing I'm going to do is I can rewrite this as the square root of y to the 8th over the square root of x to the 7th. So I can split it apart that way and work on each one separately. Now I'm going to put a little 2 here just to keep in mind how to simplify it. So 2 goes into 8 4 times with nothing left over. And 2 goes into 7 3 times, so I get x cubed, with 1 left over. Okay, now, remember we're not supposed to leave a square root or any root in the denominator. So I have to think about what I could do to get rid of it. So I know that if I multiply the square root of x times the square root of x, that's like having the square root of x squared, in which case the x would cancel out. So I would end up with an x cubed times, because the square root's going to cancel out, times an x. So I'm going to get x to the 4th power. Okay, so because this was a square root of x, I wanted to get rid of that, so I multiplied by a square root of x. Cancels out the square root, because I'm squaring that. I just get an x times the x cubed I already had, gives me x to the 4th. Whatever you do to the denominator, you have to do to the numerator. So my numerator is y to the 4th times the square root of x. And this is my answer. Now, you might look at this and say, well, I don't know that that looks any simpler. definitely, maybe not than this, but the rule is you are supposed to not have a square root or any kind of radical in the denominator to be in simplest form. So this is the strategy, and it's called rationalizing the denominator. For square roots, it's not so bad. Cube roots, this might be one that some of you have a harder time with. So I'm hopefully going to go through this and explain it to you so you can understand. All right, so I'm going to first separate it out as the cube root of 2 over the cube root of 9x. I'm even going to do something else. This 9, I'm going to think of 9 as 3 squared. So I'm going to write a 3 squared x. Now, I can't have a radical in the denominator. So because it's a cube root, I need this to be a 3 cubed, but I only have a 3 squared, but I really want it to be 3 cubed because the cube root of 3 cubed is 3. So what I need to do is I need one more 3. Because now when I multiply them, I'll have 3 squared times 3, which is 3 cubed, and then I can take the cube root of that. So for my x's, I just have an x. I need it to be x cubed. So I need an x squared over here, because then I have an x times an x squared, which would be x cubed, and the cube root of x cubed would be x. So whatever you do to the denominator, you have to do to the numerator. So now in the denominator, I'm going to kind of do this off to the side. When I multiply this together, 3 squared times 3 is 3 cubed. X times x squared is x cubed. So you see how I get the cube root of 3 cubed, which is 3. The cube root of x cubed, which is x. And notice now I do not have a radical in the denominator anymore. Now my numerator is going to get a little messier looking. It's still a cube root, so I can multiply them together. 2 times 3 is 6, and then I get an x squared. And that's my answer in simplest form. Now do not cancel this x with the x squared because this one is under a radical and this one's not, so you can't simplify that. So this is your answer in simplest form. And again, I know you might look back at this and say, that looks more complicated than what we started with. But to be in simplest form, you cannot leave a radical in the denominator. So this is probably the hardest thing from this lesson, is especially if it's not a square root, is simplifying these. So go ahead and try this one, pause it, and come back. Okay, I'm going to talk about it because I know these are a little harder. So we're going to start by doing the square root of x cubed, the square root of y to the 7th. So then we'll have, I'm going to put a little 2 here to help. 2 goes into 3 one time with 1 left over. And 2 goes into 7 3 times, so I get y cubed with 1 left over. So the problem is I can't have this square root of y. I can have a y cubed, that's not a problem. So I just need to multiply the denominator and the numerator by the square root of y. So then now my denominator, I have y cubed, and this is going to give me another y, so I have y to the 4th. And in the numerator, I'm going to have x times the square root of xy. So you should have gotten C for your answer. So for this next one, go ahead and pause it, give it a try, come back. Okay, so we're going to have the cube root of 8 divided by the cube root of 3y squared. Now you can evaluate, the cube root of 8 is 2, so let's take care of that anyway. All right, so think about what you have to multiply by. I have a 3, I need it to be 3 cubed. So I'm going to need 2 more. So I'm going to have a 3 squared. I have a y squared, I need it to be y cubed, so I need 1 more y. Whatever you do to the denominator, you do to the numerator. Can we just call this a 9 though? So I get 2 times the cube root of 9y. And in the denominator, now the cube root of 3 cubed is 3. The cube root of y cubed is y. So then my answer is C. Again, honestly, that's the hardest part of the lesson. Okay, there might be another hard part. So I might be not telling the truth, but I didn't mean to. Okay, simplifying radical expressions. The index in is as small as possible. That's going to kind of come up more in the next section. The radicand, which is the part under the radical sign, contains no factors other than 1 that are nth powers of an integer or polynomial. So that just means if you have the square root of 5 cubed, you got to do something with that. The radicand contains no fractions, so you can't have fractions underneath the radical sign, and no radicals appear in the denominator. This is what we just were working on, rationalizing the denominator. All right, so multiplying. This is a gigantic times sign, but it's just times. So when you're multiplying and they're both the same root, no big deal, because we're just going to take the cube root. We can do 100 times 10, which is 1,000, and a squared times a, which is a cubed. But now we can simplify this because 10 cubed is 1,000. So the cube root of 1,000 is 10. So I get 10. And the cube root of a cubed is just a. Remember, 3 goes into 3 one time, nothing left over. So 5 times 10 is 50. So my answer is 50a. So this one you could just work out. Okay, give this one a try. This one's similar, so you might want to pause it. Okay, so now you can multiply 16 times 4, or you can recognize this. I'm going to rewrite this just so you can see. 16 is 4 squared. Well, if I have 4 squared times 4, that's 4 cubed, and the cube root of 4 cubed is 4. So I'm going to have a 4. A squared times a is a cubed. The cube root of a cubed is a. And then I can't forget that 2. So I multiply all the number parts together and I get 24a. So our answer is B. Okay, so that changing that, I mean, you can multiply by 16 times 4 and take the cube root. That's okay as well. All right, now this is the part that I'm pretty sure we've done before, adding and subtracting radicals. So this I think you'll like better. Now, you can only add and subtract them if they're the same. So where you could multiply them even if they were different, like you can multiply like the square root of 2 times the square root of 8 and get the square root of 16. You can't subtract these unless they're alike. So what you have to do is you have to think about the largest perfect square. If you want, you can make your list of perfect squares. If you remember, we did that once before. So there's just up to 100. So 9 is the largest perfect square, so I'm going to rewrite this like that. The square root of 9 is 3 times the 3 I already had there, so I get 9 root 5. I know I did that fast, but we've done this before. So breaking down 80, if you look through this list, 16. So I can think of this as the square root of 16 times the square root of 5. So that's 4 root 5. But I already had a 5 there, so 5 times 4 is 20. Okay, and now I want to break this down. 4 goes into that, so think of this as the square root of 4 times the square root of 5. So I get 2 root 5 times the 4 I already had. Now notice they're all alike. So I have 9 minus 20, which is negative 11, plus 8, which is negative 3. So my answer is just negative 3 root 5. So I'm just combining those. This is like having 9x minus 20x plus 8x. I mean, it's really the same kind of idea. You're combining like terms. So go ahead and try that one. You might want to pause it. So we can think of this as the square root of 25 times the square root of 3. So 5 root 3. So I get 15 root 3 when I multiply by the other 3 there. This 16 goes into that 3 times, so 4 root 3. So we'll have minus 8 root 3 because of the 2. And this is already a square root of 3. So 15 minus 8 is 7 plus 1. Don't forget there's one more, so 8 root 3. So your answer should have been D. All right, multiplying radicals. If you can FOIL or put it in a box, that's all you have to do. So I'm going to do this one in a box, but it's the same idea as FOIL. So I think we did this once before too, so this might just be review. And 3 minus root 3. Okay, so we're going to multiply this out. Now, remember, you multiply the whole number part. So 2 times 3 is 6, so we get 6 root 3. 3 times 3 is 9, so I get 9 root 5. Here, if I have the square root of 3 times the square root of 3, I'm squaring a square root of 3, and I get 3. Times the 2 I already had gives me a negative 6 here. So you might have to stop and think about that one. And then for the last one, I'm going to get a negative because one of them's negative. There's only one whole number there. Square root of 3 times the square root of 5 is the square root of 15. My answer, notice that none of them are like terms, and I can't make them like terms. So I get 6 root 3 plus 9 root 5 minus 6 minus 3 root 15, and there is nothing I can do to simplify it. That's what I get when I multiply them out. So remember, you can also FOIL, but the hardest part on this probably is remembering what can get multiplied together. So whole numbers with other whole numbers, the radical part with other radical parts, and then, so just kind of keeping that straight, paying attention to plus and minus signs. So you can go ahead and try that one. I'm going to go through this with FOIL. So first we get 10 root 5. Outside, we're going to get minus 2 root 35. Inside, we're going to get plus 20 root 6. And last, we're going to get minus 4 root 42. And do we have a winner right here? I think so. Okay. That's it. Okay. And one last example. And on this one, we are simplifying. It's a division problem. Notice that we have a radical. In the denominator, we have a square root, and that's not considered simplest form. So on previous problems, we just multiplied by the square root of 3 on the top and the bottom. But look what happens. Don't write this down yet. But look what happens if I multiply by the square root of 3. If I do that, now that cancels out because I would have to distribute this, and I'd have a 3. But then I have to multiply the 6, and I'm going to have this. That doesn't help me because I'm going to still have that in the denominator. So that doesn't work. That's not the plan for there. So what we have to do, and this, if you remember in the very first slide, there was a word called conjugate. And we have to multiply by what's called the conjugate. And the conjugate is just recopy this, except make it the opposite sign. So since this was a plus, we're going to have the square root of 3 minus 6. We had this come up with complex numbers when we had an I, and we had to multiply by the conjugate. So we had this same idea kind of come up. Whatever you do to the denominator, you have to do to the numerator. So now I've got a lot of work to do because I have to simplify the numerator, which means I'm going to have to multiply this out. So off to the side, you can put it in a box or FOIL it. I'm going to FOIL the numerator, and when I do that, I get 9 root 3. That's the first. The outside is going to give me minus 54. The inside is going to give me a negative, and I'm going to have a 2. When I do the square root of 3 times the square root of 3, I get 3. 2 times 3 is 6, so I'm going to have a 6 there. And then for the last, it's a negative times a negative, so it's positive, and I'll have a 12 root 3. And I know that can still be simplified. We'll do that in a minute. Now the denominator, I'm going to multiply this out. I'm going to do this one in a box, just to show you can do it both ways. Square root of 3 plus 6, square root of 3 minus 6. The square root of 3 times the square root of 3 is just 3. Okay, now you can do the square root of 9, which is 3, or you can think of it as squaring a square root. Here I'm going to get 6 root 3. Here I'm going to get negative 6 root 3. And here I'll get negative 36. Now, when I combine like terms, notice these right here are opposites. They're going to cancel out, and I'm going to get negative 33 for an answer. That's what's going to go here. Now, this will always happen. If you multiply by the conjugate, you're going to get rid of the radical. It's always going to happen where those are going to be, they're going to cancel out. The reason why, for those of you who can catch this, this is the difference of two squares. If you remember, a plus b times a minus b is a squared minus b squared. So that is the difference of two squares, and that's really what's happening here. So we can do a little bit more because we can simplify. I have 12 plus 9 is 21 root 3. Negative 54 minus 6 is going to give me a minus 60 over a negative 33. Now, I'm okay if you left it like that. It's a little awkward because typically we don't like to leave a negative here. I noticed something else I can do as well, because I can divide the 21 by 3, and I can divide the 60 by 3, and I can divide this by 3. So I'm going to factor a 3 out of the numerator. And then notice I can cancel the 3, and it leaves me an 11 down here. So that's a little better. But it's a little awkward to have a negative in the denominator. So a lot of times what you'll see instead is multiply the top and the bottom by negative 1. So I'm not changing anything, I'm just multiplying by 1. So we would have negative 7 root 3 plus 20, because I'd have to distribute that, over a positive 11. And that's better. You could even put it as 20 minus 7 root 3. So this one was kind of complicated. You might have to go back and watch that again. You might have to look up any examples in your textbook or something if you are still having trouble with that. So you're going to be uploading a picture of your notes, and then tomorrow you will have some practice problems over this material.